Alrighty, today we start Unit 7, which is modeling quadratic functions. Our first lesson is solving quadratic equations by factoring. So let's review our factoring skills. The first problem has two terms, so that means this is a binomial. What I notice is that both terms are perfect squares. The first term being 2p times 2p, and the second one being 5 times 5. So again, when you factor a difference of squares, you will have two sets of parentheses. Both operations are appearing one time in each set. And then write the factors from the factor trees. So it'd be 2p plus 5 in one and 2p minus 5 in the other. Final answer. On number 2, we have a trinomial because there's three terms. So for the trinomial, we use the x method, where we look for factors of c, in this case 8. That will give us a negative 6. So the factors I can think of are negative 2 and negative 4, because negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. So the factors would be m minus 2 times m minus 4. Whatever variable is in the problem needs to be used in the final solutions, ladies and gentlemen. For number 3, the first thing I notice across the trinomial is that 15, 24, and 63 all have a common factor of 3. So let's factor out 3 from all terms. 15 divided by 3 is going to give me 5x squared. 24 divided by 3 is going to give me an 8x. And 63 divided by 3 is going to be 21. So now that I have the GCF outside, I still have to factor the trinomial using the x method. But before I can apply the x method, I need to slide the 5 over. That would give me x squared plus 5x minus 105. And now when I begin the x process, I'll put a negative 105 at the top and a positive 8 at the bottom. So the factors of 105 that would give me 8 are what I need to find. Hold on one second. So the factors of 105, negative 105, are 15 and 7. And I would need a positive 15 and a negative 7 to give me a positive 8 when I add them. So the factors are going to be parentheses x plus 15 and x minus 7. But remember, we slid 5 over in the beginning. So now we divide our factors by 5 now. So that would give me x plus 3 on the first and a 5x minus 7 on the second. And last but not least, bring your GCF back outside. So the final factors would be 3 parentheses x plus 3 parentheses 5x minus 7. Now notice all I did was move the denominator to the front. Make sure you do that only after you reduce the fraction in lowest terms. So now when we're going to solve equations by factoring, we first set the equation equal to 0. Then we factor the expression if possible and apply the zero product property to find the zeros. So in words, if the product of two expressions is 0, then one or both of the expressions equals 0. In algebra, if A and B are expressions and A times B is equal to 0, then A equals 0 or B equals 0. So here's an example. If x plus 5 times x plus 2 equals 0, then x plus 5 is equivalent to 0, or x plus 2 is equivalent to 0, which means that x would be negative 5 or x would be negative 2. So this is how we're going to use the zero product property to solve equations by factoring. So in equation number 4, it's x squared minus 2x minus 15 equals 0. So the first step is already done. It's set equal to 0. Great. Now we'll try and factor the trinomial x squared minus 2x equals 15 using the x method, negative 15 at the top, negative 2 at the bottom. So the factors we would need in this problem are a negative 5 and a positive 3. So the expression would say x minus 5 times x plus 3 and then equals 0. So now we apply the zero product property and take each binomial out of the parentheses. So x minus 5 and then equal it to 0. And we're going to take x plus 3 out and equal it to 0 and solve. So when I add 5 on this one, x equals 5. I'm going to subtract 3 from this one, so x equals negative 3. So the solutions to this equation are 5 and negative 3. You can leave it like I have, separate, or sometimes you might see it written in set notation. So it would be negative 3 comma 5. It's an alternative way of displaying the answers. Either one is fine. For number 5, it says 2m squared plus 7 equals negative 9m. So the first thing we have to do is get it to equal 0 by adding 9m to both sides. Your goal if you have to move terms to equal it to 0 is leave the leading term positive. So the term with the largest power should stay positive at any means necessary if possible. So after I add 9m to both sides, the equation would now say 2m squared plus 9m plus 7 equals 0. Now we factor. Before we can factor, check to see if there's a GCF. So the numbers are 2, 9, and 7. They don't have any common factors, so there isn't a GCF at this time. Now we're going to slide and divide. So slide our 2 over with the 7 would leave us with m squared plus 9m plus 14. And now we use the x with 14 at the top and 9 at the bottom. So the winning factors would be a 2 and a 7. So that would be m plus 2 times m plus 7. And now we have to go back and divide by 2. Whatever we slide is what we divide, don't forget. Reduce the fractions. So you would have m plus 1 and 2m plus 7 in the second one. And then bring down the equals 0. Now finish solving the equations by separating the binomials. So that's m plus 1 equals 0, or 2m plus 7 equals 0. Subtract 1 in the first to get m equals negative 1. First subtract 7 in the second, you'll get 2m equals negative 7. Then divide by 2. So m is equal to negative 7 over 2. So again, you can leave the solutions separate or put it in a swirly brace as follows. Now on your own, I would like for you to solve these two equations. Please take a picture, and these conclude your lesson for today.